Well, welcome to Wyoming Armory right here in Cody, Wyoming. Now, we use TIG welding pretty regularly in gunsmithing, but there are some advantages to the new laser welding technology when it comes to gunsmithing, and particularly where we're trying to minimize the heat input to our work. We're trying to not affect the temper, or we're trying to keep warpage down, or situations like that. We're really getting a highly focused weld that doesn't sink heat. And we can see we were just welding that just a few seconds ago. Now, we've been sending out our laser welding work to some other folks, and we just decided it was time to take the plunge and get our own laser welder for the shop. So we just got in this Photonics X1 Pro 700 watt laser welder, and you know, we figured we'd invite you folks along. We'll show you unboxing the thing, getting it all set up, and then some of our first set attempts at learning how to weld with the thing. And it's really surprisingly easy to weld with. Okay, so we've got a couple of boxes here. I'm guessing that probably the welder's in one box, and then there's a separate wire feeder that's likely in the other. And here's our instruction manual. Hopefully it was written by somebody who is a English speaker as their first language. Some of these instruction manuals can be a little hard to decipher from Chinese made. And unfortunately, I would love to buy American, but I did not find anything that looked like American made. So this is a Chinese made, I think. Okay, so we've got a power cable here. Looks like a 220 power cable. We've got an emergency shutdown, so I guess if that laser tries to get away from us, we can shut her down in a hurry. Okay, a ground clamp. Let's see what we have in here. It looks like a kind of a test piece here where they ran some weld beads with the machine to show that it was working. Very nice looking. I guess if you did that all day, every day, you'd get pretty good at it. Here's some lenses. Looks like some consumables here. The brass tips. And more consumables. Packed in pretty good. Yep. That's more of the consumables that we were looking for. Looks like some dark glasses. Maybe we don't need a full welding hood. I see some people in the videos just using dark shaded glasses. I'm going to think that they're specially designed for laser welding. And it looks like more lenses. So we're into a one layer now with a lot of the accessory items. Let's get into the next layer and see what we've got here. Oh, and there we have our laser gun. Ever since I was a small child, I always wanted a laser gun. Never dreamed I'd actually have one. Now I do. Okay, so it looks like this is going to come up. And it's kind of trying to pull through, so I'm guessing it's attached to the machine. So yep, the machine's underneath here, cord's attached, so we'll get it over a little closer to where we're going to set it up and get that machine out of there. And so we'll pull this out of the way, and let's look at what's in this other box. Okay. So, packing list. Oh, looks like we do have a laser welding helmet as well. And an apron. A stand for the laser gun to sit on. And we've got some tubing here, and I'm assuming that this is going to be used for the argon shielding gas. And it looks like we've got our wire feed here. So we've pretty much got everything unboxed now. I'll take a few minutes and go over and see if I can't get things set up, and maybe we'll actually fire this thing up and see what happens when we go to, I guess you call it strike an arc, or I don't know, fire up a laser or something like that. Alright, we've got this laser welder kind of all hooked up now and ready to test out. And just for perspective, you can kind of look at the footprint. It's very similar to the footprint that our TIG welder has that we use so much here in the shop. The main difference is that there's a separate wire feeder that's down below, and we'll show you that here soon. We haven't got it all hooked up yet. We're going to do some test runs without the wire feeds to start with. And of course the TIG welder has a foot pedal and some other stuff down here that we don't have with a laser welder. Both of them use the argon inert shielding gas, so we can hook it up either way there, and that's kind of handy. The plumbing for this laser welder is really kind of ingenious. It just uses some little quick detach couplers on it. It's kind of similar to shark bite plumbing fixtures, if you're familiar with those. It turns out we can use either 120 or 240 to power this laser welder, so we've just got it plugged into 120, which, you know, of course our TIG welder and our MIG welder that we rarely use here in the gunsmith shop are both 240 exclusively. And I guess that's about it. Let's fire it up and kind of take you through how to set the thing up, and then we'll see if we can't melt a little steel. Now we'll turn the machine on, kind of take you through the setup. You can see here on the face of the machine there's just an on-off key here they call an interlock. We've got an emergency shut-off here, and then our touch screen here. And let's turn it on and see how that looks. We'll kind of come up a little closer here. Okay, so we've got three different functions on this laser welder. Of course, the welding, we can cut with it, although I probably wouldn't do much cutting with it. And then we can clean with it as well. And that just basically cleans the metal off if you've got a rusty piece or something. Of course, we've got a couple of blast cabinets here, so I don't see us using that much. So we'll start off with the welding, and maybe in a future episode we'll show you some of the other features or functions. Okay, so it looks a little complicated here, but it's really fairly simple. Up here in this corner we've got the gun trigger, so that lights up when the trigger's pulled on the laser gun. The connect here, it just means that it's in red, that our ground cable isn't connected yet, so when we connect that up it will turn green. We can see up here the mode selection. We've got it in weld. The interlock is lit up red because it's turned off. We'll turn the key on. And now we've still got a warning here, which is atmospheric pressure. And that's just because we don't have our argon gas turned on yet. When we turn that argon on and it's up to pressure, then that turns green and will allow us to go. Now the next thing up here on the top, you'll see there's three metal bars there, and if we push on that, then we have a choice of different types of metal and different thicknesses, and so the thicknesses of course are in metric, from 1 to 5 millimeters. You know, 1's pretty thin, that's about 40 thousandths for those of us who still use imperial measurements, and 5 is about 200 thousandths, which is a fairly thick piece. I was really more expecting this just to be for sheet metal, but you know, a 200 thousandths piece is fairly thick. We go over here, the SUS, and they don't have, unfortunately, in the instructions what all these mean. So the SUS is stainless steel, then we've got carbon steel. This SECC, I believe, is zinc plated. Aluminum, and then I don't know what the UDT and the OTS. Now we can use this laser welder on all sorts of different non-ferrous type materials too, brasses and bronze, copper, and several others. So you know, it's a matter of setting them up. These are just presets. So if we push these, and we're going to be doing carbon steel, so we'll push the CS, and the steel that we're going to be working on is about 4 millimeters thick, about 160 thousandths. So we've got that set, and now it will preset. You notice that 32 hertz just changed. So we've got 100% power, and if we're on thinner stuff, it'll drop that power down. And of course, we can manually raise that up or lower it down. So we can go down to, say, if we want 95% or anything between 0 and 100. We can manually do that. So same thing with the swing frequency, and what that means is that little laser actually kind of wags back and forth, and so the frequency is how fast that wags, and the swing width is how wide it wags back and forth. Now we're talking about doing kind of spot welding, so you know, we'd be down here at maybe 1 millimeter width, so it's a very short or narrow wag or swing width. Okay, so we can choose between continuous, or we can choose a pulse, and for our purposes in this demonstration we'll just use continuous, but if we were to use the pulse, we could adjust the pulse rate and duration that way. Let's go back here. Gas just means we're turning the gas on, and of course we haven't physically turned the gas on, so even though that's green, we're still getting our warning light up here. Okay, we'll turn that back off. Wire feed, that just turns on our wire feeder. To start with, we're not going to hook that up, but after we play around with it a little bit, we'll hook up the wire feeder and do some automatic feed. Okay, then over here, our wire feed configuration just tells us the wire feed speed basically, and if we want to put a delay in there, or how far we want it to pull back when we're done. Go back here now, and more. And this is kind of interesting. We have something similar on our TIG welder where we can adjust some of the parameters, and so there's fewer parameters on this laser than we have on TIG, but basically it turns on the gas before the laser, so we've got a good shielding gas going around where that laser is going to be working. The rise time, and I don't know if you can make it out very well, but there's a little graph here that's showing a rise between points A and B, and then a continuous, and that's where the laser is working, and then a fall time on the back end of it. So 100 milliseconds for it rises from 0 to whatever we've got it set at for power. Then 100 milliseconds is 1/10 of a second. Okay, and then we're down here afterwards. The gas stays on for a little bit while that puddle freezes, and then it falls off very quickly, 50 milliseconds. Okay, and we're gonna go back there, and off delay means after we've taken our finger off the trigger, it's going to continue for 200 milliseconds, and I don't want that. For if we're just like pit filling, we're going to take that back down to 0. So here we just put in 0, confirm, and now we've got 0 milliseconds for off delay. So we take our finger off the trigger, it immediately stops the laser, because we're trying to keep as much heat out as possible. So we're going to weld as quickly as possible, turn it off as quickly as possible, let it cool off. Alright, so we've just got a piece of mild polished steel here that we're going to do some test runs on. Now, one of the things that I've been warned about is that from time to time these lasers can kind of reflect off of your workpiece. So ideally we'd want to be in maybe a smaller room by ourselves, or have some kind of screens around us to protect from having that happen, especially if there were other people in the shop, which there aren't today, thankfully. Which brings us to our next subject, is eye protection. Now this came with both just some, looks like some safety glasses that are tinted. We've got a welding hood here, and interestingly enough, they're just about like really dark sunglasses. In the hood itself, it doesn't auto darken or anything. We don't have nearly the degree of eye protection. Now these, I'm sure, are set up for the wavelength that protect us from the secondary laser. Of course, we wouldn't want to take that laser gun, point it right up at our eyeball, even with these glasses or the hood on, because I think the results would be pretty catastrophic. But so it is kind of nice, and these are set up so that even with my old eyes, where I need reading glasses to be able to weld these days, they fit right over the top of them, which is really pretty handy. Now, one of the things I've been fiddling around with this gun, it is a little awkward compared to some of the other welding methods. Now, I've done extensive welding with stick, MIG, and TIG, and this is probably the most awkward or least comfortable. If we are going to get up on our workpiece here, we're just way back here. We've got our trigger a long ways away from our workpiece, and so like when we're TIG welding, let me grab my TIG torch here. We can be right up here close to what we're working on real easily, or even with a MIG gun, it's a little better ergonomically than this laser, so it's going to take a little getting used to. And the laser welder itself is really set up more like a MIG welder, a MIG gun. And we don't have the wire feed on it yet, but it'll be set up down here underneath. And basically we've got a trigger here, and that wire, when it comes out, is going to make the connection. Now we're going to have a ground strap on here, or ground clamp, and when the wire goes through that laser welder, it hits our workpiece, and that's what's going to complete the circuit and create that arc. Now we have another option, and that's if we're not using the wire feed, or if we're cutting or cleaning, then we're not actually touching anything and completing the circuit. So we can actually put our ground clamp on the gun and complete our circuit. Now we have to do that if we're cutting, we have to do that if we're cleaning, and we have to do that if we're not wire feed. If we're using it like a TIG welder, and say we're going to dab that in, dab our filler rod in by hand rather than auto feed, and we'll see. I mean, this is my first time doing it, so we're gonna attempt that first and then move on. But what we have to be really cognizant of is that with this attached here, you pull that trigger, and that laser's going. And so if I'm welding on something over here and pull it off up onto my finger, it's laser welding my finger. If I pull it off over here and down towards my knee, well, then I'm laser welding my knee. Or if I'm cutting something here and I'm going through it and my foot's underneath, that laser beam is actually going to cut right through the toe of my boot and the toe of my foot. So there are some added things to really be careful about, and when you start up with this laser welding, because it's not, in some ways it's similar to some of the other processes, but in a lot of other ways it's completely different, and a whole another set of hazards that can come up. Now we've turned on our argon bottle. We're running it at about 20 cubic feet per hour. Anything below about 15 and we start getting an error warning. So let's turn on the machine here. Okay, we're welding, so we're going to confirm that we're welding. We're going to turn our interlock on. And now we're not getting that warning we were before about low atmospheric pressure. We're doing our carbon steel at 4 millimeters, which is about 160 thousandths. And we've adjusted our swing width to just 1 millimeter. Turn our gas on. And now we've got everything else set. Now we have to turn our power button on, and It says make sure you're wearing your eyeglasses, so we'll get our eyeglasses on here. And it says a respirator as well, but for our purposes we're not going to be doing enough to need a respirator. And we'll confirm that, and we're all set and ready to go. Alright, so we've got everything hooked up and ready to go now, and we can see on this gun there's an S with a green light there. Until that light is flashing, we're not ready to go, and so we don't have the ground hooked up yet. We're gonna get this ground clamp on the gun itself, and you see now it's flashing and ready to go. Now at this point, if we pull that trigger, wherever this gun is aimed, it's gonna fire that laser. So we need to really make sure of where this thing is pointed in a safe direction and where we're wanting to do our welding. So it's a lot like treating every gun as if it's loaded out on the range. Okay, so all we're going to do to start with is kind of a spot weld, and in order to do that, we're going to get that dot to where it's very focused. See, if I pull back, it starts getting really unfocused. Bring it up to where it's really close here, and we get a good focus on it, and now we'll just pull the trigger and do kind of a little spot weld just as a test. And that's all there was to it. Let's take a little closer look at it. Okay, now because we weren't using any kind of a filler rod, we can see that we just got a little pool there, and it just made kind of a little crater. You'll notice a very small heat affected zone around this. In fact, I took my glove right off after doing this and put my hand on it. It was cold to the touch. It just pretty amazing how little heat it puts into it. Now if we were TIG welding here, and this is one of the real advantages to lasers, particularly in thicker metal like this, we have to sit there and soak a lot of heat in it to get that little molten puddle going. And with those lasers, it is just instantaneous. We've got that pool going, and that's the real advantage, particularly on heat-treated materials or materials that we're really trying to keep the heat out of. Now let's add some filler rod to it and see if we can't fill that little hole up. I mean, that's similar to what we see with a big gouge ding or pit in the metal surfaces that we're working on. Alright, we're going to put a little filler rod right in that divot. Get our laser welder right on it. And okay, while that was fairly ugly to start with, I went back and I didn't get the camera turned on, but just held it steady there and really smoothed that weld out. So we'll do that same thing again here. Hold it steady here, and voila, that looks much, much better. That really was my first attempt at welding with this. It became pretty apparent that what I was afraid of, where you can't hold it like a TIG torch where you're right down there, you know, I just bobbled around a little bit. We were able to smooth it out pretty good, but let's give it another try, see if we can't do a little better job. We'll go ahead and make a little divot, and then we'll see if we can't fill it in and maybe just a little bit smoother this time. Here's our divot. And just to show how little heat's in it, let's get my glove off here. Look at that. And now we'll get our filler rod and see if we can do this a little more steadily this time. Get our filler rod right in there. All right, much better. Look at how that turned out. That's fantastic. And of course, if we had a pit or a divot in there like that and filled it that way, then we just go right back in, draw file or grind that off, polish it out, and we're good to go. So now we've kind of mimicked TIG welding, where we've got our torch in one hand and we're dabbing in some filler rod with the other. And now we'll set things up with this auto feeder and just regular old MIG wire. Now, one of the things that's really good about this laser welding is we don't have the compatibility issues we do have with TIG. You know, if we don't have just the right metals that we're joining and just the right filler rod, it can be disastrous. Those puddles just fall apart. We get all sorts of porosity and everything else. But with laser welding, heck, we could weld steel to aluminum or steel to brass or bronze and use whatever filler rod we wanted. It's really amazing that way. Kind of similar to the old gas welding that we used to do, brazing type stuff. So this is just a ER70S 30 thousandths MIG wire, and what I was using for filler rod here is what I had, so just some 4130 filler rod. So you know, I would suggest trying to keep it as compatible as possible, but it's not nearly the issue that it is with TIG welding. Alright, so we've got this wire feeder hooked up, and it's set up a little bit differently than like a MIG welder where the wire feeds right through the tip. So we've got actually a second tip right below here. That wire is aimed right down underneath this brass laser tip. There's kind of a groove down there that wire runs through, and then we've got it setting out there just far enough that laser is just lighting up the end of that filler rod there. So kind of an interesting thing. It may take a little getting used to getting that laser and that wire lined up just right and welding. So we're going to give it a shot here. We've got our sample piece out here that we welded a couple of little pits on. We're going to run a bead across this a ways, and then we've got one small pit and one larger pit that we're going to fill here with our automatic feed wire, and just see how that compares to doing it by hand feeding in that filler rod. Okay, so now remember, we're going to make contact now, so that's going to complete the circuit. So we've got our ground strap over here on our vise, and now we're just going to run a little bead. Okay, well that was pretty easy. And you can see the heat affected zone is very, very small on each side of that bead there. You know, if you were running MIG or stick, it would be dramatically wider, or even TIG would be 2 or 3 times that wide. So we're really not sinking much heat into that thing. Yeah, it's warm, but you couldn't do that with any other types of welding that quickly after being done. I mean, that was just molten a few seconds ago. Okay, so I'm going to get kind of readjusted here, and then we'll get, well, actually, we'll just get right in here to these fake pits that I've made here. This is going to be a little tricky. Aha, that's an issue. If you don't pull that wire away, then it sticks into the puddle here. Let's see if we can melt it off. There we go. All right, not bad at all. Certainly filled our little pit. Isn't the cleanest looking I've ever seen, but you know, that one right there, I'm sure we could file that right off, and that thing's filled. And again, look at that tiny heat affected zone around that. And I hit that one twice. We can see our laser, our light, right on the end of that wire. Let's put that wire right in that pit, and here we go. Beautiful, beautiful. Look at that. That filled in so nicely, and again, that discoloration or the heat affected zone, very, very small. I'm really excited about the prospects for this laser welder. Now let's try a more real-world practical test. I've got this junk 1906 Winchester 22 barrel, and it's got a couple of pretty deep dings in it down here. So we've kind of polished it off to make them stand out and circled them here so you can see them a little better. And we're going to go ahead and fill those dings with our laser welder. Now, in this trial, I'm going to turn the wire feed off and feed by hand. So more like a TIG weld. That's what I'm more comfortable with. Feel like I've got a little better control. And I may change my tune on that as I use this more and more. But at this point, I think that's the better way to go. So I'll get the camera right down here where you can see it real well, and we'll see how well we fill these real world dings in a real barrel. Okay, so we can see this closest dent or ding is fairly wide, so what we're probably going to do is kind of stitch it across. We'll just hit it with a kind of a spot weld and move over. It might take 2 or 3 different welds to get that done. I'll put the end of the filler rod in there, then the laser. Okay, and see how that worked. And actually it almost filled the whole thing on the first one. I didn't pull the filler rod back out quick enough, so it stuck, but that's not a problem. So I'm gonna, just to try to make sure that I've got that completely filled, go to the side of it here and do the same thing. Okay, I think that did it very well. Okay, so I'm gonna rotate this a little bit, and then we'll get that other one. And it's covers a little bit of area, so we might have to do a couple on it too, maybe not. Oh, I think we got them covered right up, just that quick and easy. And we can put our finger right on it already. Alright, let's draw file those off and see how they filled. Now, ignore this blob of silver solder here. Somebody had dinged up that dovetail and soldered in the mag tube hanger, but here's our 2 repairs that we did here to those dings. And those dings could have been draw filed out, but anytime you're draw filing on these barrels, you can certainly create a low spot or a flat spot on them, so much better to fill them and draw file back. And this one up on top is all but disappeared now. And this one down here, I'm having a little more trouble because I'm trying to draw file and running into that big blob of silver solder, but we'll get that one cleaned up as well. Okay, so it looks like I missed just a little edge of that over here. So we have a choice now. We could either draw file to the bottom of it or just go back and put another little dab of weld on it. And there you go. In that case, I would go back and just put another little bit of weld in there so we don't have to draw file it down any further. And that's going to be part of the learning process and getting a little better at hitting the mark exactly. Now, while I'm not ready to retire the trusty TIG welder just yet, I'm really optimistic about some of the possibilities that this laser welder presents to us and some of the things that we can do now that we haven't been able to do or haven't been comfortable with doing in the past, particularly in critical areas and keeping that heat out of tempered steels and out of areas and barrels, entire barrels, whether they've been tempered or not. So, you know, we still got a lot of experimentation to do. We still got to check out the cutting and cleaning functions. So, you know, keep an eye out for some future episodes as we get dialed in with this new and kind of exciting toy. Thanks for joining us today. Hope you learned a little something. Until next time, happy trails from Wyoming Armory in Cody, Wyoming.